Just give me 1 minute. Huh?
Please, sir.
Right. So next, I think we have around 80 plus participants here, right? Most of them are faculty from, I assume they are from various branches, electrical electronics, computer science, instrumentation and control, right? Am I right?
Yes, sir. It's a mixed faculty, sir. Mixed community.
Right. Fantastic. So the next 15-20 minutes, I will take you through some of the proposed solutions in coming up with the automotive structure, especially in the electric vehicle technologies. And the last 10 minutes, I will talk how to make the faculty and the students, engineering community, ready for taking up these challenges in the next 5 to 10 years. So if you see, I'll just skip my introduction. This was already given. There are 3 challenges when you talk about electric vehicles. One is affordability, coming up with low-cost solutions. The cost of battery, the cost of battery pack. There should be some disruption still coming in the cost of battery pack. Then only it will become affordable. At least in the case of 4-wheeler SUVs and similar. In 2-wheelers and 3-wheelers, already these challenges are met, and we can see a lot of production vehicles in 2-wheeler and 3-wheeler space, at least in the last mile connectivity. But there are some challenges when we talk about electric vehicles in SUVs, sports utility vehicle, and other city to city commute. So one of the key challenges is cost affordability, and the other one is range optimization. Range optimization, efficiency improvement of the vehicle systems. The third very important is safety, high voltage safety, electrical safety, and of course crash safety when you talk about Indian road conditions, Indian scenarios, right? So these are the 3 challenges. So what I have structured my presentation in such a way that how to face these challenges and come up with some solutions which can address these 3 challenges, and we can come up with scalable structures for automotive. So one is obviously lightweighting of structures. Lightweighting. What happens when we lightweight a structure? Obviously, the cost of the product will come down because material cost comes down, and also the range can be improved. The second one is improved powertrain. So again, when you talk about motor powered, electric powered vehicle, you have all the scope to develop your control logic, control algorithms, motor control algorithms for maximizing the range for the Indian drive conditions. So there is a scope in improving your motor architecture, your controller architecture, your thermal management system, battery management system, and so on. So improved powertrain. And the third one is efficient thermal management. So these are the 3 possible solutions which we can look at if we want to address these challenges. Right. So now, my presentation is divided into 3 parts. First, I'll talk about lightweighting. The second part would be on the powertrain efficiency, and the third part would be on the thermal management. And all these 3 solutions will help in range improvement and the cost reduction. Okay. Now, why we need lightweighting? We all know that government is pushing EV to go green, and also in IC powered vehicles, the complexity and the technology challenges are becoming more in terms of, for example, if you take a sports utility vehicle, you take a SUV, and when you talk about SUV, next 5 years, we have to meet stringent regulations in terms of emissions. So when you talk about stringent regulations in terms of emissions, we have to go towards IC engine based advanced technologies, and these technologies are costly. And when we move from IC powered vehicle to electric powered vehicle, the complexity of the system will come down. And once the complexity of the system comes down, your cost, your reliability will improve, your cost will come down. And of course, with all the efficiencies which we are talking about. Right? So this is another driver for getting into EV platforms, right? And then, right. So now automakers are developing a wide variety of advanced technologies. We are working on various improved powertrains in IC engine, drivetrain improvement in efficiencies, transmission efficiency, powertrain control logic efficiencies, right? We're also working on hybrid electric vehicles and full electric powered vehicles. Presently, These are happening. The research is happening. But fundamentally, the low-hanging fruit is lightweighting, because it directly reduces the material cost and improves the range of the vehicle, right? So next 5 minutes, I'll take you through lightweighting very quickly. So if you see the vehicle distribution, you have body in weight structures, you have trim structures, you have suspension systems, you have powertrain systems and thermal. And significant portion of, if you see the significant portion of your weight is coming from body systems, 34. So now, how to reduce the BIW, body structure weight, when we try to design an electric vehicle? Let's say you already have an IC engine vehicle. Can we replace the IC engine, and then put the electric motor ABC packs in that? Can we replace it? Do we need to do any changes in the existing IC engine architecture or in the structural design? Do we need to do any changes? Yes, we need to do a lot of. There are two ways of looking at it. One, you can start the structure from scratch and customize your structure for your electric powertrain. Because when you move from IC engine to electric powertrain, your excitation forces are changing. Right? And these are very influential. And the noise, vibration, harshness, sound characteristics are changing. So how to design your structure for EV? So either you can start from scratch, or you can convert the existing product into an EV structure with a lot of modifications in place, optimization in place. Before going to the next slide, I will talk about what's the complexity in doing the lightweighting. So automotive customer wants life of the car. It should not fail. It should not crack. The durability should be very high. And when there is any collision, right, the occupant should not be injured. It also means that the energy generated during collision should be absorbed by the structure and not by the occupant. So your structure should be capable of absorbing the energy. And when you talk about electric vehicles, your coefficient of drag at high speed, suppose if you go from Chennai to Bangalore at 110 kilometers per hour, the coefficient of drag will be very high for a present kind of boxy structures. So how do you convert your existing architectures where your coefficient of drag can come down and your tires, change in the architecture, so that your resistance comes down at higher speeds is another. And then when you try to move from IC engine power to electric vehicle powered vehicles, lot of packaging and architectural changes, because you need to mount ABC, you need to mount motor, and in the front end structure, and battery along the floor. So a lot of underbody changes should happen, along with meeting the other wiring harness, high voltage and low voltage lines. A lot of packaging studies, packaging optimization has to be done when you convert from an IC engine to EV structure. Right? Now, the other very important, which I'm showing here, if you see my cursor, the noise, vibration, and harshness is another challenge. Right? What do we mean by this? In an IC engine powered vehicle, the customer listens to the, in a diesel engine, it's a lot of vibrations and noise. But when you convert this into EV powered, the noises come down drastically. But there are certain noises which will be irritants. For example, your AC, when you switch on the AC in an electric vehicle, your noise coming from the blower will be very significant and it may be irritant. The noise coming from the tires, the noise coming from the power steering hydraulic circuit, these will be irritants. So what you need to do, you need to optimize these systems for EV. So there are a lot of challenges, and I have listed only few here in this slide. There are 20 attributes which we need to meet, and often these attributes are conflicting in nature. What do you mean by conflicting in nature? When you try to improve the other attribute may go for a ride. So how do you deal with this, right? So these are some of the challenges, right? So I'll not spend much time on this. I'll just take one example. Okay, let's say in an electric powered vehicle, imagine that this is an electric powered vehicle. Your range will come down when your AC is high. When you use your air condition, right, your auxiliary power consumption will be high and your range will come down. Battery range will come down. Right? Similarly, for an IC engine vehicle, your fuel consumption will be more. This is one example. When you try to make your structure aerodynamic, right? Aerodynamic by changing the design of the A pillar. When there is a rollover, the occupant may touch the roof because the roof will crush easily. When you have an aerodynamic design, the roof will crush easily during a rollover. The occupant may be seriously injured, head injury. So I just don't want to get into it. So there are a lot of conflicting requirements. When you try to meet the other parameter goes for a ride. So what you do is, whenever you're trying to do lightweighting, you understand the electrical electronics requirements, structural requirements, safety requirements, so on and so forth, and try to come up with a holistic optimization platform. Right. Now, so lightweighting of automotive structures can be done in multiple ways. We can have a material focus, joining can go for various joining technologies, and we can powertrain downsizing we can do. That means we can downsize the motor capacity, thereby the electric powertrain size will come down for a given occupant capacity. Right? You can work on powertrain optimization, and you can also work on thickness optimization and so on. So what I will do, next 10 minutes, I will be talking about three things. One is optimization to materials, optimization through design, and optimization through motor, efficiency improvement of motors. And then last one is optimization through thermal management. So next 5-10 minutes, I'll talk about these things in a very crisp way. So this slide is shown where we talk about optimization through advanced materials. So you can see the BAW structure here. This is BAW structure, body in weight structure. Right now, we are going ahead with the advanced high strength materials. When you go for advanced high strength materials, you can reduce the thickness of the structure, thereby you can lightweight and your range can improve. And we're also going ahead with natural fiber and graphene based composites, foam type of composites, polypropylene type of composites, in order to lightweight some of the structures like fender and bumper fascia. Am I audible?
Yes, sir, you are audible, sir.
Okay, because I am just trying to check, because if I lost the connection, I don't know whether I.
No. You're
right. Great, thank you. So a lot of advanced materials we're trying to go. For example, if you see the chassis of a structure, we go for a lot of foam type of structure, so on and so forth. So all these advanced materials can lightweight your structure significantly. You can have 20 to 30% lightweighting, and this results in significant range improvement in case of electric vehicle and fuel economy improvement in case of an IC powered vehicle. Here you can see on the right hand side how strategically you can position your materials at corners and ensure the stiffness of the overall structure, and thereby reduce the overall weight of the other thicknesses which are there. And 30% reduction in BAW structure weight through strategically positioning some advanced materials will lead to range improvement significantly. Right. So this is there. And now what I'm trying to say is we need to formulate the optimization problem, a mathematically rigorous problem, which has an objective function, constraints, and variables. Then these are some of the analysis, finite element analysis we do a lot at vehicle level, durability, NVH, and crash. And these are some of the responses which I don't want to get into detail because of the limitation in time. What I'm trying to say here is, once you do a thorough optimization, you have the potential to lightweight your structure, some of the key components. And we have achieved almost 20% reduction in mass of the structural components and more than 20% in the electric vehicle platforms using optimization methodologies, right? So the message here is, when you want to improve the range of an electric vehicle, you can work on advanced materials, you can work on advanced design optimization techniques, and then come up with lightweight structures, essentially, which will help in improving the range, right? And next one, I'll talk about improved powertrain. Improved powertrain, if it is an IC engine, you have to work on efficiencies of the intake system, exhaust system, combustion system, so on, fuel system. In case of electric powertrain, you have a lot of scope in improving. So IC engine, I will skip because of the limitation in time. I'll directly go to the electric vehicle. I just pulled up this slide because this is very core to the control systems. What was done recently is, when we talk about electric powertrain, either we can have a permanent magnet based or without using permanent. There are two options, right? So induction motors do not require permanent mode. So what happens? Our dependency of rare earths will come down when you go for induction motors. If you use permanent magnet base, then your dependency on the rare earths increases. So there is an opportunity here where you can use induction motor as your main source, prime mover, induction motor, where you can work on optimizing the efficiency. Especially induction motor is poor compared to PM motors at low speeds, right? Now, when you try to develop a control algorithm for Indian road conditions, what do you mean by Indian road conditions? Let's say you have some geographical conditions, slope conditions, right? You want to go from Chennai to Bangalore, and you know the entire geographical location, and you know the slope. Now, can we develop a control system which optimizes your control algorithm should be in such a way that it will operate in the ISO SFC zone of your motor, right? Is it possible? So there is an attempt has been made to use induction motors, which doesn't require PM, and then try to improve the efficiency at low RPMs, which is one of the drawback of this thing. And if this project gets successful, then and this would be a disruption, right? So currently, we use PM type motors, and attempt has been made to use induction motors. So this work is on, and now we have a very good lab at Mahindra Technical Academy. You can see here the entire setup, hardware setup, steering system, your drive lines A, B, C, and then your entire hill setup here, and you have a simulator, excellent simulator here, which you can simulate the real world usage pattern. And then you have a hardware setup just adjacent to this lab where you have two motors, one act as a loading element, and another is, and then you also have the battery packs in place. So this is an architecture of the lab what we have, and then this is the setup. So this is a old diagram. Now in the recent we have completely had set up this, and now a lot of experiments are being done in this lab to optimize the powertrain for Indian road conditions, especially for SUV platforms. And the last one I will talk about. So you heard about lightweighting through structure. You heard about improving the efficiencies of the motor will help in increasing the range. And the third one is thermal management of EVs. Very important. So what do you mean by thermal management of EVs? In India, you have various ambient conditions. A vehicle can go in Ooty, a vehicle going in Himalayas, a vehicle can go in Rajasthan, where the ambient temperatures are completely different. And these ambient temperatures, depending upon the ambient temperatures, your customer will operate the AC. Now, how can you ensure? Because the battery operates at a particular temperature. Battery efficiencies will be maximum at certain range of temperatures. How can you ensure that your battery temperatures are in the optimal range, irrespective of the ambient conditions? Do you need to design different systems for these varying ambient conditions, or is there a way to optimize the same system can go for various operating conditions? So an attempt has been made to a detailed study was done, both 1D and 3-dimensional analysis on the battery management system and thermal management system. And this is where you see a model, a physics-based model, where you have cabin model, then you have electric powertrain and battery cooling model. And then this model, we run the vehicle drive cycle was run based on real world usage pattern, right? And then this model is giving, simulation versus experiment. We have close correlation between simulation and experiment. And once we got confidence in this model, after running the drive cycle and seeing at the energies, we use this model for the high level optimization. So here you can see ambient temperatures. For different ambient temperatures, what is the range which is possible? Because the objective is to improve the range. The point here is, when I go to an ambient temperature 38 to 40 degrees, what should be my cabin temperature target and battery temperature targets? These kind of outputs, optimized temperature outputs we got based on this physics-based model. Now what happened? The control algorithm, what it does, the moment it sees this ambient temperature, it sets the cabin temperature and battery temperature to this in order to achieve the maximum possible range. That means your control logic algorithm will use this strategy to ensure that for varied ambient temperatures, you get the maximum possible range. So this is another attempt. So what you are trying to see here is, you saw three aspects. One is the range improvement through lightweighting of structures. One is the range improvement through improving the efficiencies of the powertrain, right? And one is the range improvement through thermal management. Of course, at a high level, because at 20 minutes, it's only possible to show these insights. Most of the things we have published in public domain, I can share the detailed papers, which shows detailed formulations. So what we are trying to say is, when we try to go and develop an electric vehicle based platforms, it's very important to lightweight, to improve the efficiencies, and to manage thermal, and to manage your heat loads based on the real world usage pattern. So these are some of the key insights you can actually get from this presentation. And now I am done with presentation. And last 5 minutes, I would like to I would like to take few questions. Before going to questions, I would like to advise the participants on few things, that the next 5-10 years is very tough when you talk about EV platforms. The reason behind, we are looking at engineers who are highly multidisciplinary. What do you mean by multidisciplinary? A combination of mechanical, electrical, electronics, controls, and software engineering. So your syllabus should be structured in such a way, the projects what you're doing, the hands-on projects or the experiments you're doing in your final SEM should be highly multidisciplinary, working, on highly multidisciplinary teams. That's one takeoff. And the second one, what I'm trying to say is that most of the one second. And the second very important point is the lot of disruptions having in data science and AI, communication technologies, the 5G is coming up, and a lot of computational power is increasing. And people are talking about quantum computing. So a lot of data is getting generated, right? Now, so even the mechanical engineer or electrical electronics engineer should become expert in data science, AI and ML, machine learning. This is another very important thing. And he should get into, so even a mechanical engineer should get into electrical electronics and control systems, advanced control systems courses. So at least some portion, 70% can be the mother bench, but the last 30% should be highly multidisciplinary and give a lot of flexibility to the participant to get into any product design. Today you are seeing automotive systems in this lecture, but the same requirement is when you try to go into a aerospace or a marine or any other product, as a matter of fact. So with this, I'm trying to conclude, and then thanks for giving me this chance to interact with the participants, and I am ready to take up any questions.
Dear professors, our speaker is available on the platform. Kindly raise your questions. Please unmute yourself and I request the professors once again.
Hello, sir.
Hello.
Hi.
Hello, sir.
Yes, please.
Sir, namaste, sir.
Namaste.
Is there any initiations and research going on for heavy vehicles?
Right. So you're talking about bus and trucks, right?
Yeah. Yes.
Yeah. A lot of things are happening in that space. Because again, there the electric vehicle makes a lot of sense, because again, within the city commute, let's say a bus, electric bus, it has a lot of potential. So the 2-wheeler, 3-wheeler and bus within the city, a lot of things are happening, and a lot of scalable architectures have come up in EV space in that.
Okay, sir. Thank you.
Hello.
Yes, please.
Hello, sir. Good afternoon, sir. So I have one question regarding battery thermal management.
Right.
So my question is whether nanofluid will work properly for battery thermal management system, if we use nano fluid with along with dielectric fluid, or if we use a nano fluid along with heat pipe?
Right. So actually, again, this is a research problem which you're talking about, Sagar, right? Sagar
Yes,
Vanke.
sir. Yes,
Right.
sir. Yes.
Sagar, what you need to do is, if you see my presentation where I have shown the one-dimensional model, right? You have a cabin model, powertrain model, right, and a battery
Yes,
thermal
sir.
model, right? What you need to do is, when you talk about nanofluids, you need to also have a three-dimensional computational fluid dynamics model, 3D CFD model, where you link that 3D CFD model with this one-dimensional model and use the nanofluid, and try to understand the ranges obtained by the way when you are trying to cool your battery to achieve the required operating temperature. So my answer is, you need to really explore using simulation models with the kind of material you are proposing. And definitely, and a lot of literature is available in using nanofluids.
Yes, sir.
It's a good idea. Please go ahead and try to simulate. But what I'm trying to say is, you have to simulate not only at the component level, but at the vehicle level.
Yes, yes. Okay, sir. Thank you. Sir, please share your PPT. Share all your PPTs and, if possible, share your recordings, sir.
Definitely, sir. I'll recording also. I'm recording, and I'll share with you all the recordings at the end of the day. I request all the professors to switch on your videos. We are collecting some photographs from this. Please cooperate with us. Sir Srinivasan, sir, please. Sir, principal, sir.
Yes.
Please switch on your video, sir, please.
Please.
Professor Aditya, please. Niveda, ma'am. Please support us, cooperate with us. A few seconds, please, to help us. Aditya, sir.
Hello, sir. One more question.
Please, sir, please proceed while we'll take the snaps. Vasudevan, sir, please. Tilekarsi, ma'am. Ramesh, sir, please, all of you. Ishwari, ma'am. Dr. Mahalakshmi, ma'am. Shalini, ma'am, please. Sindhu, ma'am. I request all the professors, please. Mahalakshmi, ma'am, please. Shalini, ma'am. I request the GRG staff, please switch on your videos. Jairam, sir, Prabhu, sir. Ganesh, sir, please. Mutturaman, sir, please. Okay, thank you, professors.
Hello.
Professors, I think somebody is asking the question. Please continue.
Hello, sir.
Yes, please.
Sir, is there any simulation software available open to simulate the EV?
Right. So very nice. Desai, I will give my contact details. You can contact me. You can note down my number straight away if you have pen and paper.
Okay, sir. Tell
Sir,
me,
I would like to share with you, sir, in the schedule,
So I
have shared with you through mail. In that itself, I have mentioned all the speakers' contact details and mail ID. You can make use of the schedules, sir. They're shared with you through mail, and even WhatsApp group also we have shared the same. All the speakers.
But they say you can directly contact me. I will help you with the open source code available.
Okay, sir. Thank you, sir. Madam, have you shared that today's resource person details?
There in the schedule itself.
Okay, ma'am. Thank you.
Yeah, please.
If there are
Some
no further
professors have
questions,
come forward to give their valuable feedback. Please, ma'am. Please, professors.
Thank you, madam. I am
Thank
Dr. Arnga Babu, working
please,
as head of the Department of Price Taking Engineering College. Throughout the 5 days, your program organization was too good. Also, the quality of the programs too good. The topics which I came to know so many recent technologies that has been taking place in this electric vehicles, and also I found some good research topics related to that, so that I can carry out my research work in this particular domain. Even though I didn't belong to this so much, I am not so much familiar to this topic. I find so many research topics related to this. Thank you, madam, for organizing this type of FTP programs. I am expecting more from this institution. Thank you, madam.
Thank you, sir. Thank you, Dr. Arnga Babu, sir. Thank you so much.
Mudavali ma'am, please.
she's on mute.
Hello, good afternoon, ma'am. Hello.
Good afternoon, ma'am. Please, ma'am.
Ma'am, I am M. Ishwari,
Hi.
working as senior lecturer at SSI Institute of Technology, Trichy. Hello, ma'am.
Please,
Audible?
ma'am, please continue. Thank you.
Okay, ma'am. Ma'am, thank you so much to all coordinators, all resource persons. I feel so much happy. More informative sessions, ma'am. Thank you. Thank you once again. It is very useful to Polytechnic, because our end scheme syllabus, electrical vehicle, is one of the major subjects. So it is so much useful for this situation. Thank you all. Thank you once again. Thank you, ma'am. Hello, ma'am. Thank you.
Thank you, ma'am. Thank you so much.
Thank you. Thank you so much, ma'am.
Okay, ma'am.
Now I request Anthony sir, HOD Automobile Engineering from Ramkrishna Polytechnic College, to share the feedback. Sir, please.
Tillikers, ma'am, thank you so much, ma'am, for your blessings and wishes also. Thank you.
Thank you very much, Indra ma'am, and thank you, Dr. Shankar Subramanian sir, Principal, GRG. Really, all the sessions were very awesome and wonderful, very informative. Thanks to all the resource persons, and thanks for the wonderful organizations.
Yes,
Thank you.
ma'am. You people are all our well-wishers, madam. Kindly support us and bless us for upcoming events also, ma'am. Thank you.
Thank you,
Thank
madam.
you. Thank you, ma'am.
Mudavali ma'am.
Thank you all for your valuable support. And now I request our Professor Uma Maheshwari ma'am to propose the vote of thanks.
Thank you, ma'am. Pleasant good afternoon to all. As all good things come to an end, so with this faculty development program it is my pleasure to propose vote of thanks to those who have directly or indirectly contributed to this, to bring this AICT Atal sponsored 5 days FDP a grand success. On behalf of our management, principal, all staff members of our GRG family, and on my own behalf, I would like to express my sincere thanks to our chief guest, Dr. Ranga Srinivas Gunti, Deputy General Manager, Mahendra and Mahendra Group, Chengalpattu, for his enlightening and useful valedictory address for this AICT Atal sponsored 5 days faculty development program on electric vehicles, research issues and challenges from 23rd August 2021 to 27th August 2021. Thank you, sir. I would like to express my heartfelt thanks to AICT Atal for sponsoring and sanctioning this program. It is my duty to express my sincere thanks to our management for their continuous support and motivation. It is my pleasure to propose my heartfelt thanks to our beloved and dynamic principal, Dr. A. Shankara Subramaniam, for his encouragement, guidance, support given to us. Thank you, sir. I would like to express my sincere thanks to all the resource persons, Dr. M. Venkatesh Kumar, Assistant Professor, Amrita School of Engineering, Chennai, Dr. Naveen Kumar Marathi, Architect, Electrification, Electric Vehicles, Center for Excellence, Wipro Limited, Bangalore, Dr. V. Sankara Narayanan, Professor and Head, Department of EEE, National Institute of Technology, Tiruchirappalli, Mr. R. Rajkumar, Senior Application Engineer, VI Solution, Bangalore, Mr. Esaki Raja, Senior Application Engineer, VI Solution, Bangalore, Dr. Dinesh Balasubramaniam, Postdoctoral Researcher, Kon Keen University, Thailand, Dr. C.S. Subhash Kumar, Associate Professor, PSG Institute of Technology and Applied Research, Coimbatore, Dr. S. Devanayan, Director, Innovation and Entrepreneurship, Meenachi Academy of Higher Education and Research, Chennai, Mr. S. Esekimuthu, Senior Design Engineer, Renault Nissan Automotive India Private Limited, Chennai, Dr. D. Ravindra, Associate Professor, Department of EEE, GRIET, Hyderabad, Mr. Chandragat Vioda, Senior Technical Delivery Manager, New Delhi, Professor B.L. Gupta, Department of Management, NITTR, Bhopal, Dr. P. Muruganandam, Deputy Registrar, Indian Institute of Information Technology, Kalyani. I would like to express my sincere thanks to all the resource persons for their presence, their tireless effort spent for their preparation, these special lectures, and for their presentation given in 5 different topics in these 5-day span. A special thanks to the organizing committee, coordinator Dr. A. Shankara Subramaniam, Principal, GRG Polytechnic College, and co-coordinator Dr. K. Indira Devi, Head of the Department of Instrumentation and Control Engineering, and our team members for their support and team spirit. Our heartfelt thanks to all the participants and the principals of respective institution for permitting their faculties to attend our FDP. Once again, I would like to express my heartfelt thanks to the heads of various departments and faculties of GRG for making this FDP a grand success. Thank you all.
Thank you, professors. Srinivas sir, thank you so much, sir,
Thank
for
you.
sparing your
Thanks a
valuable
lot.
time with us.
Yeah, thanks a lot. And I my best wishes to the entire team and the participants and the college management and principal. My best wishes. Right?
Thank you, sir. Thank you so
Okay,
much,
thank
sir.
you. Bye.
Now request the professors to wait for a moment to post the assessment link. Please stay back. Please wait a minute. Yeah, the assessment link has been posted. Sure, ma'am. Deepa ma'am, we will share all the recordings with you. Not only with you, to all the participants through mail. Dear professors, you will find the overall feedback link also. Oral feedback link and attendance. Kindly attend these two till 8 o'clock today. Take your own time and please fill all these forms. By 9 o'clock, we will close the response. Kindly cooperate with us.
Hello, madam. Is sharing in the mail or to the this one?
Which one, sir?
This one assessment and.
Now we have posted, sir.
Where you posted into the chat box section?
Yes, sir. In the chat box only, sir.
Okay, fine.
Okay, thank you.
Madam.
Excuse me, ma'am.
Please, sir.
What is the time of submission of the quiz?
Yes, sir. You can take. That is why I'm saying the Google form is accepting responses till 8 o'clock.
8 o'clock.
Yes, till evening 8 o'clock. You can have this time, sir.
Okay.
Because now it is weekend. That is, otherwise within half an hour I can close the link, sir.
Okay.
Because in some
We can
areas,
submit our
this is
response till 8.
weekend. Sorry?
We can submit our response till 8.
That is why, sir. That is why I'm telling. Because it's a weekend in maybe some areas. There's a weekend. So people may travel from here and there. That is why we are telling that Google response will accept the responses. Google form will accept the responses till 8 o'clock.
Okay, madam.
Probably 8:30, I will close the responses.
Thank you.
Hello, ma'am.
Yes, ma'am.
Ma'am, actually, I'm having one doubt.
Please,
You
ma'am.
have posted so many feedback links, ma'am.
No.
But I have filled all the feedback links from the first day itself.
Madam, that is for day-wise attendance,
So
ma'am.
is there any separate? Okay. So
That is
where
day-wise
actually
attendance,
that,
ma'am. To monitor your attendance day-wise.
But if we have filled already, then no need to fill up again, no, ma'am.
Today's you have to fill, ma'am. This one.
Only for today. But what is the link
Not
for
only for
quiz,
today,
ma'am?
ma'am. All the days.
But if we have filled it already, then also we need to fill it again, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, okay.
Okay.
And what about quiz, ma'am?
Quiz you have. Assessment is compulsory, ma'am.
You have posted for the same.
Yes. In the chat box, you will find the link for assessment too.
Okay,
Please
ma'am.
check it
Okay,
out.
fine.
Yeah.
Thank you. Thank you.
Thank you.
Hello, madam.
So please.
Yes, sir.
There are so many links are there, madam. So each and every link, I will find the same forms.
Sir, for the benefit of participants, we have done, sir, because people used to ask, where is the feedback link or where is the assessment link? That is why we have done.
Ma'am, each and every link have same Google
Yes, sir.
form.
Yes.
Yes, yes, ma'am. Okay, ma'am. I already
Please.
filled all the attendance throughout the this FDP or so now I can fill all I can fill only this assessment link.
Sir, this assessment link and overall feedback link is for today, sir.
Okay, okay. So this is one feedback form, no?
Yes, sir.
Madam, actually, what is problem is you are sent so many times. So that's why the people are problem with that.
So people are joining.
Repeatedly, you are sent in the chat box. No, they're confusing actually.
Okay, sir. We'll stop sharing.
Yeah.
No, just sort out which is attendance, which is
We'll
assessment.
stop sharing, sir. We'll stop sharing.
Madam. Excuse me, madam.
Yeah.
Madam, even the participants have to fill the feedback in Atal portal also, no?
Yes, sir. Atal portal, you have to fill the feedback link, sir.
Thank you.
I hope that everybody is attending the assessment. Now we are ending the session. Thank you so much for your untired support and cooperation for conducting this FTP in a successful way.
Hello.
Please, sir.
Have you sent that link to our mail also?
Which link, sir?
This exam link means.
No, sir. In the chat box only.
Okay.
That is why we have sent many times, sir. Because in meanwhile, people are joining and going out. They may ask, link, please, link, please. That is why we have done it repeatedly. Please copy it somewhere and fill it up, sir. Thank you.
Yes, because I am filling it in the chat box only by clicking on
yes,
chat
sir.
box.
We will do only in the chat box.
Okay. So please don't end this session now. So wait for 10-15 minutes, madam.
Sure. Okay, sir. Because I have to close it unless until I end the program, it may not start recording. That is why. I will wait for 10 more minutes, sir, please.
But ma'am, assessment link you are updated into the WhatsApp actually.
Sir?
Yes or no? Assessment link actually you are copied into the WhatsApp actually.
No, sir, we haven't.
But it is there into WhatsApp. It is different. Yeah. DM assessment link. They sent somebody. That's why I'm asking. You just see the WhatsApp group.
Sir, somebody in the participants.
Oh, they copy and paste it.
We haven't.
Yeah.
Please see the who has posted.
I don't know. That's why I'm asking question.
No.
Ma'am, you can delete that one, ma'am. You can delete
that.
That
is done by someone, sir.
Because
DM.
Multiple things
Some participant
again.
DM has posted.
Yes, sir. People are, the thing is, people are not keep quiet. They're sending. Okay, anyway.
Sir, now the technology is in our hands, sir. We can do anything. Anybody can do anything.
Madam, just call him to, don't send, even make the group admin only message, change the setting.
Settings ಮಾತಾಡಿ Uma. Thank you all. Thank you so much.